Okay, this video is going to show you how to go from moles of one substance to the mass of another substance. Okay, so this is the opposite of the video that I did where we started with mass and ended with moles. And it's basically the same thing, just flipped backwards. So here's the formula you would end up using. And essentially what we're going to do is we're going to go from moles of A, then use our mole ratio to get to moles of B, and then we're going to use our molar mass conversion to get from moles of B to mass of B. So that's kind of what these three fractions are right here. Okay, so whenever I get a problem, I'm going to underline my given, and I'm going to circle what I want, and I'm going to check to see if we have a balanced equation. We have all three of those things, so we're chilling. So I'm going to go ahead and start with my first fraction. It's going to be 1.89 moles of nitrogen monoxide over 1. Okay, so we have that fraction done. Now, to successfully set up a Stoich problem, you're always going to take whatever unit and substance you had up here and put it directly diagonal before you do any numbers. That kind of helps give you a guideline or a map of where you're supposed to be going. So now that I have moles of nitrogen monoxide on the bottom, I know I'm going to start needing my mole ratio because I'm at moles of where I started. And the only way I can translate between two different substances is by using my mole ratio. So I'm going to end up wanting to put moles of whoever I want on the top so that I can get to whoever I want to then get to the unit that I want. Okay? So almost always in a Stoich problem, you're going to be using the mole ratio regardless of how many fractions you have in that problem. Mole ratio is like the most important thing, in my opinion, in this unit because it helps us to do whatever we want. So when I see mole divided by mole, that's a red flag that I need to go look at these numbers right here. Okay, so a 4 is next to NH3, so I'm going to put a 4 next to this NH3. And there's a 6 in front of that NO, so I'm going to put a 6 in front of that NO. And I'm going to go ahead and I'm going to cancel out my unit and substance, cancel out my unit and substance, as long as they're diagonal with each other. Okay, and now I can go ahead and move to my next fraction. So I'm going to put directly diagonal moles of NH3. And then I'm going to try to get to my wanted. And luckily, we know how to get from moles to grams, so I can do that in one fraction. A big mistake that I see people do is that in this second fraction, they'll put grams of NH3 already. And it's like, whoa, you don't have a relationship in one fraction to be able to say, hey, this many grams of NH3 is equal to this many moles of NO. It's like they're skipping a step. So just be careful. The only time you can ever switch substances in a fraction, see we have NO on the bottom and NH3 on the top. The only time you can do that is when you have moles and moles the same. Okay, so just be careful. But we do have grams per mole. And when you see grams per mole, that's going to be your molar mass. And again, really quickly how you do your molar mass, you're going to figure out who's in your compound. So we have 1 nitrogen and 3 hydrogens. On the periodic table, the mass of 1 nitrogen is 14.01. So 14.01 by 1 is itself. And then the mass of 1 hydrogen is 1.01. And 3 times 1.01 is going to be 3.03. We're going to add those bad boys together. This becomes 17.04 grams for every 1 mole. Okay? And again, that's validated right here in our formula. Molar mass divided by 1 mole. I'm going to take a new color and make sure that my... Oh man, that is ugly. Oh no. Okay, sorry. I'm going to make sure that those cancel out. And hopefully you're seeing this diagonal pattern kind of happening here. Okay? So now we can solve because we're at our wanted, right? Grams of ammonia. So I'm going to say equals, and then I'm going to do 1.89 times 4 times 17.04, and then I'm going to divide it by 1 times 6 times 1. And when I put this into my calculator, it's going to end up being about 21.5 moles, no, grams, I'm silly, right, because I ended with grams. Grams, I need to erase that, it's ugly. Grams of NH3. Okay, so if you just follow your formula, or if you just follow this pattern that I've been showing you, where you do the same unit and substance, then you should be fine.